Alright, hi. Mastering Solidworks. Alright, creating simple parts and drawings. Good modeling practice based on a robust design intent. This just means that you should try to build parts that adapt easily. The change section of the book begins with the things you need to know in order to make good models. Models are react predictability in drawing. The update properly with a chain with a robust design intent will be making the downstream operations easier. Creating simple will help you to understand the techniques used in more complex modeling projects. Learning on simple tools, expanding with the skills will help you understand best practices, issues. You will make the better contributor to the team environment. In this chapter, you establish design intent, build a simple part, create a simple assembly tutorial, and make a simple drawing tutorial. Discovering design intent. By knowing the right information about the parts function before you start with the modeling and designing, you can create the model that will easier to edit, easier to properly place into assembly, easier to detail into the drawings, easier for other SolidWorkers users to understand when someone else has to work on your models. Design intent is a statement of how the part functions, the major features of the part, how the model will react when the model changes. It may help if you try to put the design intent with the words to help the focus on what is important to design. With example, the statement with the design intent with this part that's symmetric about two planes is used to support a 1 inch or diameter diameter shaft which constantly downward load of 150 pounds using bronze bushing is bolted to the plate below it. This does not give it enough information for the design of the part, but it gives you information about the two surfaces of the important, a hole with the bushing and a bottom of the touch of the mounting plate, as well as some general side of the loading requirements. Using symmetry. Symmetry is an important aspect of the design intent to take advantage of the symmetry with significantly reduce the time needed for the model of the part. The symmetry can exist in several levels: sketching symmetry, individual feature symmetry, whole part symmetry, axle symmetry, a revolved part, almost symmetry with the whole part symmetrically, even except with a few features. Left and right opposite hand symmetrical versions in this part, and assembly symmetry. Determining primary with the function feature of the probably most important information for the known with the primary function features include with how to the part mounts and connect with the other parts in motion that needs to accommodate with additional structure support loads. Often it is a good idea to create a special sketch for the first feature for the part with the lays out with a functional feature for this could be as simple as a straight line to denote at the bottom and a circle to the represent with the position seizing with the mating part, or as complex as a full outlines of parts and features from all three standard planes. This technique is creating a layout sketch. It is important to technique the both simple and complex parts. You can use the layout sketch for anything for simple drawing and size reference bounding boxes to create one over the point over the reference and all sketch features in this part. You can also multiple layout sketches if a single sketch on one plane is not sufficient. Predicting change. When marketing department gets out of the meeting at 4:45 p.m., the changes do not need to be prepared so that they can still be laid out on the door at 5 p.m. No one expects you to be able to tell the future, but you need to know model in such a way that your modeling is easily adapts to the future changes. As you gain experience with the software engineering design process, keep this in mind. You will develop some instincts for the type of the modeling that you do. I've talked a lot of the whole success look like a good design intent model, but let's talk a little bit about it. Failure. Failure will turn out to be more motivating in practice. The design intent of the fail, you get the feature tree out of the full of errors you have to go through each of the feature and investigate what's wrong and then fix it. Failures are generally due to error of the parent and child dependency following with original change. Fixing errors can take up much more time than creating a model in the first place. This is in essence biggest weakness in history-based modeling. There are a few ways to solve it. Be very careful when the method fails. It is mostly due to the fact that you cannot predict the future. How will a change happen? Use a method like a resilient modeling, the structure method, where you keep your track of the parent and child connections. Only start with the new sketches on reference geometry with the direct link below back something that will not change the origin or base planes. Use methods other than history-based design that would require different software packages. Solidworks, in fact, cannot do what is known as direct modeling, although the company will tell you otherwise. I discussed this issue again in Chapter 12, Editing, Evaluating, and Troubleshooting. Creating a simple part. Chapter 2, Navigating SolidWorks Interface, introduce the tools and features you will use to create simple part. The chapter teaches you how to string simple features together intelligently. In this section, I'll show you how to build the simple part shown in Figure 4.1. Although the shape is simple, the techniques you will discuss here are applicable to a wide variety of real-world parts. The discussion on how to model the parts contain the information on some topics you must understand in order to do work. Figure 4.1 shows a simple machine part. Deciding where to start. Deciding where to start can be more difficult than it sounds, especially for the new users. For this reason, I go through some sample parts to discuss possible starting points. Figure 4.2 shows the first part. For this reference of the part is found with a widely go master solid. As you discuss how to model geometry in SolidWorks, you should be thinking of 2D shape in the process. Typically create a prismatic shape by using extruded features and round shapes using a revolving feature. Features can also be added boss or remove by adding material boss or removal material cut. Obviously, your first feature must add material. If you look at the 3D geometry, a series with a 2D drawing view arranged in 3D spaces shown in Figure 4.2, you are on the way to deciding where to start. Alright, Figure 4.2 shows starting the sketch is best. And now it shows in Figure 4.2 with the flat and round surfaces, but if you create the overall shape with a single extruded, the best option in this case would be to start with a sketch like one of the lower right hand corner extruded. This is a good beginning, although you can make some parts starting from 3 sketches and one, and the one in the lower right hand corner gets you the closest final shape. Also realize you do not need to make geometry in single feature. It often must best to use multiple feature elements with the holes, filled, and chamfers over the groups of the geometry that can be separated out of the main shape. You may look at the part and see many ways, but the greatest, most straightforward way to extrude is the U shape, the rectangular cutout with the 4 chamfers and file shown in Figure 4.2, 4.3. 4.3 show the breakdown features of this part, make out the rectangular cutout, and then extrude a main U shape and create a 4 chamfered corners. Notice whether the point and place in the relation for the origin. Different people might do it differently. The same person might even do it differently depending on the function of the part. In this case, the origin is aligned with the center of the round shape at the bottom of the flat face. Placement of the origin suggests that the part sits on a flat face with another part that may hold the cylindrical face with another part, and the option of the part widely goes to the if you open the part with the widely go master solid hyperlink, you will notice if the original or the origin is placed in the middle with the extrusion depth that suggests that the part is symmetrically through the front and the back. If you are new to the 3D modeling, you might be too much to take in all this at once, but you should keep the ideas presented here in the mind as you work through the first level of the parts. When you examine SolidWorks, parts must be more experienced users, made by more experienced users. Figure 4.4 shows another part of the feature, again using choose from several ways to make this part, and show the identifying the best starting point of the part. And now you've seen 3 faces of the part, and in this case, the best option would use the one on the top. The other 2 profiles would add geometry that would have to remove later. Notice the holes in the part would not represent within many profiles. Any of the profiles, the basic holes often in separate features later that gives you the control over where the holes are, and not as well as the side of the placement of the holes. Returning to part Figure 4.1, it should be clear enough that this part would best be started with a rectangular, although the rectangular could come from any of the 3 directions. I personally try to use the biggest sketch that will create the solid required with the fewest number of additional features. The first feature that you create should be positioned relative to the origin, whether the corner of the rectangle is coincident to the origin. The rectangular is centered on the origin dimension of the well stand of the rectangular off from the origin some distance. You need to lock the first feature into the origin every part every part you build. Many people ask how to move the origin, and this perhaps is one of the first things you need to understand about working in SolidWorks. You do not move the origin in SolidWorks. You move everything else in relation to the origin. If you have the part built with the origin in a certain place and want to move it depending on how the part was built, this might be a very big job. If every feature was created with dimension from the origin, you will have to move every feature. Features created with a dimension from the edge of the first feature only need to move with the first feature, if possible, move with the entire body, but if the more complex operation, this will be addressed later. When working with the simplest part of the entire part can sometimes describe the rectangular cylindrical. In this case, like it is easy to know whether to start with a simple drawing of the rectangular circle, the respectively. On complex part that may be obvious where to start with the overall part cannot be said with have any simple shapes. In any case like these, it may be best to select the A prominent feature of the mounting location, function, shape, the focus of the mechanism. For example, it might be a reasonable location as you would plane with the centers of the wheels, the end of the crankshaft of the engine is often used the assembly origin of the automotive modeling. As long as everyone working with the project agrees, many different reference forces could work within that mind, and it seems logical to start at the rectangular part with the stretching of the regular rectangular. Select the top plane and sketch these center point rectangular center on the part of the origin. Building symmetry. Your next decision about this part, symmetry of the part with the figure 4-1, but not completely symmetrically with the modern, molding a quarter of it and modeling a quarter of it in, if the mirroring entire model with twice must be, if not, must be effective technique. Instead, you should build the complete part around the origin, mirror individual features as appropriate to start with the symmetry with the need to sketch the rectangular center of the origin, again, to some extent with a personal judgment. Sketch a center rectangle where the first point of the center point is created at the origin. Drag or click the second point, one of the corners to the approximate side to create the symmetry in both of the directions. You can use the additional construction geometry. Sketch the relation to make with the rectangular symmetrically side to side only. Tip: to make a rectangular work like a square, use equal sketch relation to the adjacent sides. This requires only a single dimension to drive the size of the square. Beginning with the rectangular, you should get for the preceding section, apply one horizontal dimension, starting with a smart dimension tool with a single horizontal line, placing the horizontal dimension of 4 inches, clicking on the vertical line, placing the vertical dimension at 6 inches. The sketch is fully defined at this point. Both sides and position of rectangular has been established. Figure 4-5 show the sketch at this point. 4-4-5 show the dimensions at 4 and 6, and the boss extruded from the sketch plane, direction, and the dimension and feature. Making it solid. Extrude feature is one of the staples of the SolidWorks modeling. Depending on the type of the modeling you do, extrude feature may be one of your main tools. This section describes the available extruded options. Extruding from a selection. The from panel establishes where the extruded feature starts. By default, SolidWorks extrudes from sketch plane. These other options available: the surface face and plane. The extrusion begins with the surface body face of the solid with the referencing on the plane is shown in figure 4-6. Surface features are discussed in detail in chapter 32, working with surfaces. So here we've picked out a surface, shooting a surface. We've now picked from surface and plane, boundary, surface 1, blind direction, depth of 1.21 inches direction. And we've not collected direction 2 or thin feature, and we selected contour, sketch, contour 1. Your vertex, the distance sketch plane, the selected vertex is treated as an offset distance. So the vertex or the distance sketch plane, select the vertex is treated as an offset distance. Offset, you can enter for the explicit offset the distance. You can change the direction of the offset. Understanding direction 1 and direction 2. Direction 1 is always in the direction of the plane normal. The plane normal for the face of the solid is always away from the solid. For the reference plane, the interface will show you the normal direction with the arrow with the creating and editing. Direction 1 and 2 are always opposite one another. Direction 2 becomes inactive. You select the mid-plane with the end condition numbered direction 1. In the graphs window, you will see the single arrowhead of direction 1, double arrowhead in the direction 2. For blind end condition, which is described next, the dragging the arrows determine the distance of the extrusion. Each end of the condition is effective with the reverse direction toggle. The toggle simply changes the default direction by 180 degrees. You need to be careful when using this feature, particularly when using the up to end conditions, because the etny that you're extruding up is not to the selected direction of the arrow result. Ending an extrusion. Following with a brief description of each of the variable condition with the extruded feature. Blind. In this case, blind means explicit distance. The term is usually in conjunction with a hole's specific depth, although here it's associated with the boss rather than a hole. Up to the vertex. In fact, up to the vertex works like a blind end condition, except that the distance is parametrically controlled by the model vertex, edge, and sketch point. Up to the surface would probably be a better name for up to face, because the end of it does not necessarily have to be actual surface feature body. The end condition may be displayed with a warning of if the projection of the sketch is onto the selected face extends beyond the boundary of the face. In this case, it is advisable to knit several faces together into a surface of the body and use the up-to-body end condition. Your offset from the surface by default, offset from the surface extrudes until it reaches a specified distance from the selected surface. There are two methods of determining the type of the offset, one with a determined direction. Default offset method behaves selected surface well, where offset radially, so the surface within 4-inch radius and 1-inch offset would give the curvature on the end of the extruded 3-inch radius. The second method would be translate surface behaves as a surface where moved by offset distance. And then reverse offset refers to specifying whether the offset stops or short of the selected face or goes past it. Those are figure 4, 9, 2, top and bottom. Up to the body end condition, very useful in many situations, especially when you receive the error message. The end face cannot terminate the extrusion from the up to surface end condition. Mid-plane end condition eliminates the direction 2 options. Divides the extruded dimension equally into the both directions. For example, if you specify 1 inch of mid-plane, Solidworks extrudes a ½ inch in one direction, ½ inch in the other direction. This is a useful option in ensuring symmetry and direction normal to the sketch plane. Alright, now you're seeing the offset of the surface by default, offset from the surface by translating surface option, reverse offset option. I don't know if I got that. The through all end conditions available only with the solid geometry already exists in this part. When you use the extruded boss, which adds material to extrude to the distance of the farthest point of the solid model with the direction perpendicular to the sketch plane. When used for a cut, it simply cuts through everything up to the next extrude of the feature until the running into the solid face completely intercept the entire sketch profile portion. Sketch hangs over the edge of the face. The extruded feature keeps going until it runs into the condition that matches the description, which may be outer face or part of the direction of extrusion. Figure 410 show that the up to the next condition, you've the cut extrude. 410 shows up to the next extrusion. You've now got the green box and the yellow and the blue box. And then you can see the bolt right there. We've used up to the next extrusion. By default, direction of the extrusion is normal sketch plane, but you can always select a linear entity, especially for the edge of the planar face for the plane axis for the direction. All of the end condition options are still available to manually define direction of the extrusion and something other than default. You can also assign draft option to the extrusion as is created. You can control the draft separately with the direction 1 and direction 2. Best practice, arranging draft, fillet, and shell features the correct order so that the model is efficient, achieve the desired result. Challenging, usually best to apply draft seems a separate feature rather than using definition extruded feature. It also best to apply with the draft after most of the modeling is done, but before you apply with the cosmetic fillets, before you use the shell feature. Use the thin feature. Use the thin feature panel. Thin feature panel is activated by default when you try to extrude an open loop sketch, a sketch that does not fully enclose an area. The end condition option remains the same. What changes is the feature applied with the thickness to the sketch elements for the manner of the sheet metal part, thin wall plastic part, or rib. The thin feature panel with the extruded property manager along represented with the thin feature extrusion shown in figure 411. So in 411, we've used a thin feature panel extrusion, and we've given that one direction and a tenth of an inch dimension. The cap ends option is available only when you specify the thin feature to be created from a closed loop sketch. This creates a hollow solid body in a single step. You can also use the thin features with the cuts and very useful creating slots or grooves. Alright, using contour selection. Solidworks stretch is the easiest to control with the stretches with the neat and clean. When nothing overlaps, you have no extra entities exist. However, you need to use the sketch that does not meet the criteria. You can use the contour selection as an alternative method. Contour selection enables you to select area completely bounded by sketch entities for use of the features such as extrude. For example, you could use the sketch like a number sign, pound, where the lines do not connect at ends. You could use the contour selection, select the box in the center, which is completely bound by sketch element. Figure 4 12 show the extruded feature making use of the contour selection in the sketch. At 412, show the using contour sketch. You have the boss, and you've picked from the sketch plane. You've left it to blind direction. You've left the dimension at 5.5 and 55 hundredths of an inch. In direction 2, you didn't select it, but we selected contour selection regions. And no, this part is using the image shown 412 available to the Wiley.com Go Master Solid is called Chapter 4 Contour Selection Solid Print. Best practice. I believe the contour selection introduction Solidworks only keep up with the other CAD package if it's not. Because of the great feature, I do not recommend using the contour selection on the production models, useful creating quick models, but selection is too unstable for the data to be that may want to rely on the future. The main problem is that the sketch change with the selected area may also change Solidworks, may lose track of it entirely. Alright, using Instant 3D. Instant 3D enables you to pull handles, create extrusion, and drag model faces with the change with the size, location features. Several features that enable you with the arrows to adjust elements, visually parametric features like sketches. Figure 413 shows a ruler added to Instant 3D, shows arrows added by Instant 3D, which are handles that may pull the created solid from the sketch added existing feature. Notice that all that you can make cut features with the Instant 3D and Instant 3D. In fact, you change the boss feature into cut. I'm sure that this is a neat sale demo trick, but I'm not aware of any practical application changing boss into cut. Figure 413 shows interface in Instant 3D. Alright, so now you've seen the using Instant 3D live selection. This is intended functionality look and feel direct modeling, but it's not direct with but it's not direct modeling. When you can do still limited, but by the feature of the history of the tree, sketch of the dimension, driving the design intent. Well, these may be handy for making quick visual changes to the model. Is not a great method of precise modeling. Instant 3D can also be an effective tool when used in conjunction with the direct editing type of the tools, such as the move face. Instant 3D mimics some of the direct edit type of the functionality found in applications such as Solid Edge, SketchUp, and Space Claim. Note, when combined with the sketch setting override dimensions on drag found in tools option sketch override dimension on drag and move, Instant 3D can be a powerful concept tool even on full dimension sketches. Alright, so Instant 3D also offers a tool called Live Section, which enables you to section apart with the planar drag edge of the section regardless of the features to which the edge belongs. To activate Live Section, right-click the plane, the intersect part, and select the Live Section plane. Live Section was shown in Figure 413. Change Chapter 37 to use imported geometry to discuss the direct edit theme and the more detailed revisits for the Instant 3D manipulators in that light. Making the first extruded feature. Going back to the Sketch 4.5, I will show you how to continue building using the newly learned tools by centering the sketch with the origin extrude with the mid-plane end condition. Initial block is built symmetrically about 3 standard planes with the part origin in the center. In many parts of there is a desirable situation enables you to create the mirrored feature of the standard planes, helps you to put the parts together later. When the parts must be centered, do not have a hard to face-to-face connection with the other part. Figure 414 shows the initial feature with the standard planes. Alright, so Figure 414 shows the initial extruded feature centered on the standard planes. So we're in this from sketch pane, mid direction 1, mid pane 1.97 tenths of an inch. And that's when you create the feature of the sketch, Solidworks by default hides and absorbs and consumes the sketch only with the feature manager. So unless the tree is in a flat tree view mode, you need to click the plus sign next to the feature to select the tree sketch in the tree. You can right click the sketch in the feature manager to show the graphics window. The mesh modeling ship the groove with the back of the part. Here's the feature going to be made. There are several techniques to create the geometry list of the technique that can you think of whether or not to how to use them. Figure 415 shows multiple methods of creating of the groove, left to right. The methods are thin feature, cut, swept cut, and nested loop sketch. Figure 415 shows methods of grooving. We have thin cut feature on the left. We have using a center line over the groove in the cut extruded feature. And assigning width and depth. The option on the right is a nested loop because of the loop around the outside of the slot, another around the inside. Only the material between the loop is cut away. The method in the center is a sweep cross section is swept around the path to make the cut. Another potential option could be the large pocket being cut out with the boss adding the material back in the middle. Each option appropriate for the specific situation. The feature for the cut of the properly the fastest grade, but also the least common use of the technique of the feature for this type. Many users not even aware of the thin feature unless attending with specific training and read about it in some of the many other books. Most users tend to use the nested loop option, one loop inside another, because it enables specific geometry more directly as opposed to specific geometry and directly using combination sketches and feature settings. Controlling relative to the side of the direct dimensions. You control the side of the groove with an offset of the edge of the existing part. You can drive the dimensions independently. You can give the dependence on the type of the changes you anticipate. If the groove will always depend on the outside of the part, the decision is easy to go with the offset of the outside edges. If the groove changes independently from the part, you need to recreate the dimension relation with the sketch to reflect the different design intent. The decision how to control the size of the slot is something if putting it into the context of the design intent. But another way of looking at it is some of the SolidWorks users like me are focused on the 3D model. Many users, however, need to focus on 2D drawing. If that's your situation, decide on how to control the 3D model comes down with the dimension you want to on the 2D drawing. You can take the dimension from the 3D model and put them directly onto the 2D drawing. If you can do this, it saves a lot of time. Sometimes through the way that you create 3D parts is probably going to be different. However, you want to show the part of the drawings. Both methods work. You have to decide how you want to create your parts and how you want to create your drawings. SolidWorks includes tools for the model-based definition, or MBD. This method is where you document 3D parts separate from 2D drawing. Chapter 41, Facilities Design Tools, covers model-based definition methods and detailed drawing, starting in Chapter 24, Automated Drawing, the basics. Alright, creating the offset. You need to consider one or more of the following before creating the groove sketch. What you should use to create the offset of the actual block edge of the original sketch. The answer to this is best practice issue. Best practice. When creating relation for the need to adapt the largest range of change with the model, best for the goes back of the model history. You should pick up those relations in most cases. The means for the creating relations of the sketch of reference geometry rather than the edges of the model. Model edges can be fickle, and especially with the use of fillets and shape of the draft. The technique of the relating feature for the driving layout sketches help you to create models that do not fail through widest range of the changes. One tool to help you easily with the parent-child relation between feature of the dynamic reference visualization found in View User Interface Dynamic Reference Visualization. Much of the SolidWorks software is created with initial ease for the use of the mind. Sometimes doing the what's easily initially creates complications later in the design process. Use a way to create with a slot with the open sketch of the back face, the offset with the sketch of the edge of the face, and then apply the sketch fillets in the method. They're very fast, but but it's not very robust, meaning that there are several ways in which errors can happen, and in the end, it's not really bulletproof way to create a model. Each method has its benefits, potential problems. Video. Watch video tutorial Wiley.com Go Master for demonstration making simple part. You can follow along if you like. Finished parts also supply them with the downloadable materials. Creating a simple assembly. An assembly is a special document type of the SolidWorks that allows you to position multiple parts with respect to one another. The geometrical mate relationship, such as coincident, the concentric, the direct relationship, such as the dimensions. Simple assemblies. You begin with creating here with a single part that is located with respect to the assembly origin and standard plane with a this is very much like an orientation for a sketch for the part of the part's origin. Parts can be added to the assembly with a number of ways made together using reference geometry faces. Best you can use the reference geometry because it's like planes and axes tend to be more stable than the edges of faces. Made with the change of the layer with the remove of the face of the assembly of the make depends on when the mate fails and does something unexpected. SolidWorks assembly documentation can be extremely complex with patterns, layouts, in context, virtual parts, subassembly, flexible subassembly configuration, assembly features, exploded views and context features, special tool, box features, assortment of other assembly only tools available. For the purpose of the chapter, we will talk about putting the parts together with its mates. When creating an assembly, give the careful thought of the selection of the first part. The first part of the component of the assembly should be kept in the keep component. The assembly of the bicycle frame would be added first, locked into place until the assembly plane using the assembly planes. Similarly, an assembly plane of an engine would be started with a block where the block is fixed in assembly and origin. Like other document types, the Solidworks assembly start from templates. Before you get started making lots of assembly, you should make sure that you have at least one custom template that you intend to use. Special settings common with the assembly templates used in plain names with a different standard for the custom properties and other items. Assemblies have a featured manager arrangement of their own. If the assembly feature manager you find in parts sub-assembly special folders for mates, components, part items, assembly features, toolbox, parts, and features other assembly specific items. Alright, creating the assembly. To get started with the assembly, click with the new assembly template, double click it, and the setting with the coming up with the property name of the topic later chapter with starting with the chapter 13, building efficient assemblies. You can insert any of the current open parts or the graphic assembly with the browse window with a double clicking the file name. You can insert any of the current open parts or assembly shown in the browse window, double clicking the file name, and then clicking in the graphics window to play for the part or the assembly figure 416. Notice the assembly has some folders and reference geometry just like part documents. As added parts onto the assembly, they will be listed in the feature manager. Very large assemblies require some special techniques to manage all the data, but for now we're starting simple. Population assembly can use the shovel message of the putting into the assembly. Click make an assembly part assembly for the title bar toolbar. Choose insert component. Drag the part with another SolidWorks window. Drag the part from the Windows Explorer. Use the library in the task pane. You use beginning assembly property manager. Control drag to make a copy. Control C or Control V to copy and paste parts. Alright, show the creating a new assembly. You begin in the new assembly, and the feature over here shows an open file with the part assembly. The message graphic insert placement in the graphic area. Hit OK at the origin. Design top down using layout blocks. Part may be then created from the blocks, and then it shows your open document parts and browse thumbnail options. Start command creating new assembly. Automatic browse when creating new assembly graphic view. Making virtual envelope show rotate context toolbar. First part you put into the assembly allows the automatically fixed means into the not move it any other parts you have with no constraint mates unless you're adding them using the smart mate references explained in the chapter more details. Chapter 14 getting more from your mates. Examining mates. Mates work very much like the sketch relations, but they work in 3D space with the mates. They relate edges and faces and vertices of different type of the reference geometry to one another. They do this in order to position and orient parts with respect to one another, but also to allow for the motion when a part is dragged from with a cursor. Common mates are coincident, concentric. Again, just like sketch, the relation mates are not just for positioning parts, but also used to establish design intent. In the assembly 417 shows the assembly feature manager with the shovel components and some mates. So now we've gone to the feature manager, and now we've gone to mates, and it says coincidental, concentric frames and distances assembly. So under mates, you would find your coincidental or your concentric, and maybe the distances. Creating a simple drawing. CAD salesmen have been telling us for 30 years the 2D paper drawings are going away. 2D drawings never go away, but they will happen less for the drawing in 3 views for the individual line and arcs. Although AutoCAD with a proper product with tedious for the view creation, drawings in SolidWorks are really automated snapshots of model from various views. Any change of the model automatically updates all views. You can make selection views, auxiliary views, cutaway views, other special views quickly when working from the 3D model. There are sometimes expectations that automated updates include the models aren't loaded. Setting detached drawings when your intention is not updated with the create the new drawing. You again start with a drawing template which contains the document specific setting such as units, drafting standards, and so on. You also might use a format which determines the paper size, has the drawing border with the title block and other items. So use the template in the drawing file for the overall setting. The format is the drawing border. Using templates are saved in the format within the button, so blank drawing already has the sheet size and a border. You can make drawings of individual parts or assemblies, and you can make the multi-sheet drawing with assembly on the front or all detailed parts of sequence sheets. Drawings can also contain tables such as bill of materials, general tables, whole charts, and other types of noted charts. You can also make drafting views, simple sketches using useful layout schematics and items that may not have physical representation. Figure 488 show the drawing with some simple views, dimensions, and annotations. Alright, tutorial creating a simple part. You go to new, create the simple part with a chapter from scratch for these sets. Alright, the icons will be left in on the left side. With a click on the new icon with the title bar, toolbar, select inch part template, include with the inch part template with the downloaded materials. Open a sketch on the front plane. So now your simple drawing with the views and title blocks. Sketch a certain rectangle that is 6 inches tall, 4 inches wide from the start of the origin. Create an extruded feature using the direction 1 option mid-plane with a depth of 1 inch before accepting the extrude. So we've now extruded the rectangle about 6 by 4 inch with a depth of 1 inch. So now we're 4 inches tall, 4 inches wide, and depth of 1 inch. To create a groove, follow these steps. Open and sketch on the face the part of the parallel to the front plane. Create with the offset. Expand with the feature with the clicking the plus icon next to it in the feature manager so that you can see the sketch. Regardless how it displays here, the sketch appears before the extruded with the part history. Right click in the sketch. Select show the expanded with the display manager. Click with the icon first column in this row that the sketch will want you to show. Tip, you can view the individual sketch reference geometry entities such as planes with the right mouse button menu. The global setting of the visibility of these items are found with the view menu. You can access these items faster using view toolbar, linking the commands to hotkeys. Right click on the sketch with the graphic window, select chain. Select any of the non-construction end-to-end sketch entities. The offset entities of the sketch toolbar offset with the inside of 4/100ths of an inch and apply a 500-inch sketch fillet to each of the corners except on the outlet fillet under the green check when the fillets have been applied to the sketch. Fillet command using the green check when applied. So using the fillet command using the green check when the fillets have been applied to the sketch. Check that. Click extruded cut into the feature toolbar. By default, the extruded cut will cut away everything inside of the closed profile of the sketch. Lock down with the property manager window. Select these checkboxes on the top of the bar thin feature panel. Make the cut setting with a direction of 1 inch bind or direction 1 blind, 1/10 of an inch, and then thin the feature. And then the thin feature type should be set to mid-plane width of 4/100ths of an inch, and the property manager graphics window should look like in figure 419. So now we have the cutting, the thin feature cut, thin creating cut. We've went to cut to extrude. We've pitched the sketch plane. We're a direction of a blind. We're a 1/10 of an inch in depth, and we've pictured thin feature mid-plane direction 2 mid-plane. 4/10 of an inch. So, using sketch techniques, continue with the part previous section, follow these steps. Open the new sketch large face opposite from the groove, draw an angled line across the part as shown in figure 420. Sketch 1 should be visible. Click on the extruded button. You will be prompted to close the sketch loop. Use the yellow arrow to select the smaller loop. If you continue with the recommended best practice to make relations with the sketch rather than model edges, here are a few tips. Some situations, such as the current one, the sketch plane is offset from the sketch so that you want to make the relationship. The best bet is use a normal to view the new obstacle to making sure the automatic relations pick up the sketch rather than the edge, so you can use selection filter, use select sketches entities only. Extrude the sketch to additional 1/4 inch material. Choose the tools option sketch. Ensure the prompt to close sketch is turned on. Then click OK in the dialog box. Open another new sketch on the same face. Then use the last extrusion. Begin with drawing another angled line before placing a second endpoint over the cursor over the angled line created with the previous feature from the highlight orange. Now with the position cursor approximately to the make a parallel line dotted yellow inferences will appear. Drag the angled line using all automatic relation with that appropriate as shown in figure 421. 421 shows the closed loop angle side. We've now moved the angle side is 1.75. Angle is 75 degrees. Closed sketch model edges reverse direction to closed sketch. The parallel relation will not be applied automatically as shown in figure 421. The line will be parallel to the slanted edge relation made to be applied manually after the line is created. Time relations are applied automatically based on the inference lines when only the mouse hovers over the sketch and even not at the edge. In this particular case, the relationship will be replaced by the dimension between two parallel lines. In step 5, no redundancy parallel relation is needed. Using automatic relationship, now we've done the line at 75 degrees, 1/4 inch down. We've used automatic relationship, and then we've dimension at angle line such as 2 1/4 inches from the first line. Use the same technique in step 1. Make a closed loop extrude of the feature using through all end conditions so that all the waves match to the previous extrusion. Alright, using the hole wizard. Next feature you will apply with a pair of the counterboard holes. The Solidworks has a special tool called the hole wizard that can either create common hole type. The hole wizard helps you create standard hole types using the standard custom sizes. You can place holes on any face of the 3D model, constraining them to a single 2D planar face. Single feature created by a hole wizard may create a single hole, multiple holes, or a feature that is not constrained to a single pane that can create individual holes originating from multiple faces, non-parallel faces, and even the non-planar faces. Holes may go different directions. All holes are a single feature that you create by using hole wizard must be the same type and size. If you want a multiple sizes types, you must create the multiple holes. Create multiple hole wizard features. Apply counterboard holes that you add to your part. Follow these steps. Select the face groove. Select the face that the groove feature on it was created on. Click the hole wizard tool on the feature toolbar. Then set the hole to the counterboard standard ASI inch. The type of socket head cap screw size to 1/4. Then end of the conditions through all shown in Figure 422. Click the Select and Position tab at the top of the Property Manager. Click the Select Position tab on the top of the Property Manager. This is where you place the center points of the holes using sketch points. If the often useful to create construction geometry to help you line up and place the sketch points, make sure the plane or face that the holes originate with the Selective of the Position tab. Draw two collinear construction line horizontal across the cutting part with a coincident relationship to each other. The select of the both lines give them equal relation with the point of this step to give the parametric relation to evenly spaced holes across the part without dimensioning equations, and refer to Figure 423. Although supplements exist for the multiple selection, a box window selection technique may be useful in this situation. If the box is dragged from the left or the right, only items completely within the box are selected. If the box is dragged to the right or to the left, and any of the items least partially in the box is selected, select with a common point with the two lines. A applies the equal relation. Alright, you've seen the square little blue thing on the side. This place the sketch point with a midpoint each of the construction line. If there's a sketch point other than the two, then you want to make in the actual holes. Delete the extra points dimensions. One of the lines down from the top of the part is shown in Figure 423. All the sketch relation icons displayed with a reference. Click OK to accept the feature after you are happy with all the setting, location, relation of the dimensions. Figure 422 show the hole wizard hole specification interface. Show the hole type, the position, your favorites. No favorite selected. Hole type shows counterboard, countersunk, tapped, and some other ones over here. You can choose your ANSI standard type of socket head, cap, screw, hole size, specification, fit normal, show custom size, end through all, head clearance, near side countersink, underhead countersink, and far sided countersink. Placing the center points of the holes, and then figures 1-9 show the dimensions, center points. Alright, cutting a slot. Solidworks provides two types of slots. Hole wizard slots and selected sketch slots. Fancier slots within the counterboard's countersink can be made more quickly using a hole wizard, but hole wizard is able to create only straight slots. The curved slots you will need to be using curved slot sketch and the extrude of the sketch. As a cut in this tutorial, we create curved slots to the cut slots in your part. Follow these steps. In this case, the 7-port arc slot option. Slots are easier to create with the click method rather than click and drag. Make sure the sketch one under the boss extrude is shown. Open the sketch of the face of the groove with a groove. Click near where you want the center of the curvature of the slot. Click again in the center of the one end. Click the third time for the width and the end radius. The slot property manager is shown in Figure 424. Alright, so now we picked the slot. We've given the existing dimension for 4 underdefined. Added, you can either fix or fix slot. Option for construction: X and Y, radius, angled, and inside dimension, outside dimension. and that's creating a slot. Create a vertical sketch relation between the origin center point of the slot. Make the slot with a ½ inch wide. One way to do this is to place 1/4 inch radial dimensions on one end of the arc. But the more interesting way to do it is hold down the shift key. Click both of the big arcs in the Smart Dimension tool. This will give you the difference between the arcs. Continue with the dimensions shown in Figure 424. Using the added dimension option of the slot property manager can help you size the slot more quickly. This does not require the enable on-screen numeric input option to be turned on. From this sketch, create an extruded cut of the 1/4 inch deep. Once you sketch the bottom of the previous slot, offset the slot to the inside of 11 hundredths of an inch. Create cut using through all the end conditions. Creating a fillet and chamfers. As mentioned earlier, it is considered best practice to avoid using sketch fillets when possible, using featured fillets instead. Another best practice guideline is to put fillets at the bottom of the design tree, at least after all of the function features. You should not dimension sketches to the model edges created by fillets unless no better methods are available. Several chapters could be written on those about fillet types, techniques, and strategy in SolidWorks. Chapter 7, the modeling with primary features, deals with more complex fillet types. Best practice: do not dimension sketches to model edges that are created by fillets. All the previous best practices about relation sketch techniques instead of the model edges was mild warning. You must heed this one more carefully. To add fillets and chamfers to your part, follow these steps. Initiate fillet feature. Select 4 short edges on the part. Select the radius value of the 6/100ths of an inch. Click on OK to accept the fillet feature. You can use the first icon to the left of the pop-up toolbar as shown in Figure 425 to help you select all 4 edges around the part quickly. Tip: when selecting edges around the 4 sides of the part, the first 3 edges are usually visible, but the 4th edge is not. You can select an invisible edge by expanding the fillet options panel for the fillet property manager. Select through the face option. Or when you have the complex part with the many hidden edges, this setting can be bothersome, but simple cases like this is useful. Figure 425 shows that the selecting edges using the context board. You've now picked the fillet, you picked the features and feature type, and the fillet you picked on edge number 1, show selection, tangent, propagation, full preview. Your fillet symmetrical, 6/10 of an inch, and you profiled it circular, setback parameters, and fillet options were not used. Apply chamfer to the edge of the angled slot through the part with the indicated in Figure 426. Make chamfers have 50,000 of an inch by 45 degrees. Chamfer observe many of them same practices as fillets. Alright, feature orders. Important features like chamfer the fillets because of how they both tend to propagate around tangent edges. Although you can turn this setting off for both types of features, it is best to get around correct geometry by applying features in order. Edges for fillets and chamfer fillets. Now you have fillet edges, chamfer edges like the chamfer edges to select and on the left, and then chamfer fillet edges is on the right. And now we've select the 4 edges that indicated in the fillets in Figure 426 at 5/10 of an inch. 5/100ths of an inch radius fillet. Apply at least 5/100ths of an inch chamfer to the backside of the counterboard and slot. Save the part is chamfer for a simple machine part and then close it. This finished part simple must be learned, may be useful technique along the way. Tutorial: making simple drawings. SolidWorks drawing views are created with a 3D model, but every more complex section views are almost free because they are simply projected for the 3D model. When you make change with the 3D model, all 2D views update. You can handle dimensions in a couple of ways. Either the dimension, either create the model with placing new dimension on the drawing. Best practice for the model is not necessarily the best practice for the manufacturing drawing. Model-based definitions covered in Chapter 40 using model-based design. To make simple drawings on SolidWorks native part for the following these steps: click the new button, standard toolbar, choose the file new with the new SolidWorks document window, select the blank drawing template. Template contains all document-specific settings. After selecting the drawing template, sheet format size dialog box appears as shown in Figure 427. This only appears with the format not already in the template. If your template comes up with a border around it, you can change the border and format it by right-clicking on the Sheet 1 feature manager and selecting Properties. Select the D landscape sheet size as well as the format automatically associated with the sheet size. Click OK. The model view property manager appears. Click the red X icon to X. If the template you selected already has a format, you can skip these skips. So now looking at the sheet property dialog box, we've now moved to sheet properties. You give it a name, a scale, a type of the projection, third name, the view label A, datum label A, standard sheet size, only show standard sheet size, display sheet format, custom sheet size, use custom property model shown in default or same sheet as the document property, select sheet to modify, update all properties, apply changes, and cancel or help. Alright, from the left you see with the drawing toolbar, click on the standard 3 view button through the menu, choosing insert drawing view, standard 3 view. The chapter 4 simple machine part of the document does not appear on the list of the property manager, then browse the button to select it. When you click on the OK button, the 3 drawing views are created. After creating views of the drawing, set up the sum of the field with the format filled out. Automatically, when you bring part into the drawing, right click anywhere on the drawing sheet on the paper to select the edit sheet format. Zoom in the lower right-hand corner of the drawing. Notice that there are several variables of format, as is in dollar paper print sheet. Description: these annotations are linked to custom properties. Some of them have properties with the values, such as the scale notation. Some of the properties do not have values, such as description. Then you see a dog-noted paper at the annotation to a drawing row and date and column. You can add annotations choosing insert annotation note and activate the annotation toolbars in the command manager, clicking the note button in type today's date and the text of the note. Caution: if you're using Solidworks default template, a circle appears around your note. Using text format property manager that appears when you're creating the note, expand the border and panel, change the circle option to none. Alright, 7. Add another note time with the name of the column. Do not type anything in the note. Click on the line of the link of the property button with the note property manager. Create a link to the custom property, the link to the property with the dialog box. Click the model and drawing view. Specify the option sheet property type. The use of the drop down text box below the option now active for the custom property within property assembly that is put onto this drawing called user, and it puts the value where the note is placed. To return to the edit sheet mode, out of the edit format mode, select edit sheet from the right mouse button menu. A little text reminder appears to the lower right hand corner on the status bar to indicate whether you're editing the sheet or the format. Drawing views can be sized individually for each sheet. Sheet property dialog shown in 427 shows the sheet scale. If this is changed, all the views on the sheet with the use of the sheet scale are updated. If you select a view and activate the drawing view property manager, you can use the scale panel to toggle from use of sheet scales to use of custom scales. Alright, caution: sometimes the United States SolidWorks software installs the ISO standard template. The ISO drawing templates project views of the first angle projection. This check the project method, the use of the drawing method of drawing. Right click of the drawing sheet, select sheet property to this type of the projection setting appear at the top middle of the dialog box shown in figure 427. Alright, then it shows that to create an isometric view, activate the drawing toolbar command menu, click with the projected view button, then select one of the existing views, move the cursor at a 45-degree angle. If you cannot play with the view where you would like to go, press the control key to break the alignment and play with the view where you want it. 11. You can change the appearance of the drawing view in several ways. View to display the tangent edges with the font, with the phantom line, with the type of any of the edges with the tangent face. View display tangent edges and completely removes any tangent edges that are not recommended, especially for the parts of fillet edges, because it generally displays just outline of the part. Shaded wireframe modes can be used with the drawing in or accessed from the view toolbar. Perspective views must be saved in this model with the name of the view of the place in the drawing using the view name. Real view drawing views can be placed on the drawing. Real view can be shown with the drawings on the shaded with the edges of real view turned on. Look at the custom property that created in the title block. The date is thereby because you enter the specific value of the button. The name of the field is not filled in. This is because there is no user property in this part. Right click on the part with one of the views, select the open part with the part of the window, choose the file property for the property name column with the column type of the property name, user's value with the initials, out of the view of the company, and identifies people's on the drawing. The property dialog box also causes summary information is shown part figure 428. Note: when using models and formats, custom properties is extremely powerful combination, especially when using when you want to fill in data automatically in the format of the bill of materials or a product data management product. This topic are discussed in more detail in Chapter 13. Your custom properties entry table shows a summary and a information summary custom. You have the bill of material quantity, property name, date, and value, type, text, expression, evaluated, and when you flip back to the drawing, you have the control tab. The name of the column contains the values of your value or of your initials. Alright, now you see like a cutting plane. This collects, click on the section view button of the drawing toolbar that activates the section view with assisted command so you can place a section line in a view. If you need a cutting line other than the single straight line, the property manager has some options. The other option will be presented after you place the line to allow you to edit it. Bring the cursor down to the midpoint with the top of the edge part of the midpoint is active. You can use the dotted inference line to ensure that you are lined up with the center. Another option is to manually create a sketch for relations, turning on the temporary axis of the display center, mark center, fate arcs, and circles. Shown in figure 429 show the technique interference lines being used. So now we use the section view with the crossing section view assistant. This is the section view assist. We've picked on the section. There's either red or checked half section. Select cutting line, place it on the view. Open section view, pop up to add offset of the cutting line. Or select auto start section view with immediate preview placement of the section view. Show the cutting line and several different angles to go for. Also start section view. As mentioned earlier, you can use the two fundamental differential methods for dimensioning the drawings. Model items imports dimension. Use the build of the Solidworks model. Use them on the drawing of the dimension of the bidirectional associative, meaning the changing of the drawing update of the model, changing them on the model updates them into the drawing on surface of the things that sound to be good to be true. It is the potential problem is you might not model things the way you would dimension them and from the shop. You have the answer to several the question for yourself. Do the leader lines go to the right locations? Can they be moved? The dimension usually comes in such a way that they need to be moved around quite a bit. Reference-driven dimensions can be applied with the drawing view directly. These are only associated with one direction, meaning that the measure of what is there, but they do not derive size of the position of the geometry. All changes that must be made with the model. Again, evasive things that appear redundant and wasteful of time, but in my personal estimation, by the time you finish reading and realigning dimensions, checking to ensure that you have everything you need and hiding extraneous dimensions, you are usually far better by using reference dimensions. Alright, best practice. Users have a strong opinion of the both sides of the issue of the dimension drawing, but the best thing for you to do is both and to decide for yourself. If you choose the model items approach, you can do with the choosing insert of the model items. Specify whether the dimension should come from the entire model just to select the feature. You also need to ask yourself whether the dimension should come into all the views or just selected one. Whether you want just a certain type of dimension or the annotation reference geometry. 18. After dimensions are brought in, you need to move some of them from one view to another. You can do this by shift plus dragging the dimension from the old location to the new location. Control dragging, predictable copies of the dimension. You can move the reviews by dragging the edge of the format. Sheet versus sheet format. With a new and even experience, this is some confusing around sheet versus sheet format issue. Part of the confusion of the Solidworks terminology. Solidworks names two of the items sheet names the two items sheet and sheet format. In this book, I simply use the term sheet and format to avoid linking the two items to the common first name. That is better for that format would change to border or title block as some of the name of the more closely matched to the function. Just be aware the title block has a precise meaning in SolidWorks. There are commands associated with it. The SolidWorks drawing your editing view of the sheet of the format. When editing the sheet, you can perform actions such as view more creative views. You can select to move the edit of the lines text of the drawing border. Editing the format, you can edit the lines text of the makeup of the drawing border. Put the drawing views disappear. Also, you can edit the notation of the format from the sheet layer. Often users use save the template that already contains the format to save it themselves sometime every time when they create a new drawing. Chapter 24 covers the setting up the annotation of the drawing creation. Alright, the bottom line, SolidWorks data is made with the parts on some of the drawings. In this chapter, you learn how to create simple examples of each type. The simple block with the holes in it with every type of the dimension fully using existing SolidWorks template. Master it. Create simple assemblies when you bring together some of the parts that you created working within this chapter. View the mate to locate them with respect to one another. Master it. Create a simple drawing and single the part with the mate earlier within the chapter. Fill in with the musket with the costume property to make sure the properties propagate with the overhead to fill out the style block of the drawing using various types of view notions and symbol dimensions. Chapter 5. Using visualization techniques.